Hello everybody and welcome again to the lecture series of linear algebra. So, in this session we are going to discuss some more problems on Gaussian elimination and row-reduced echelon form. In addition, we will also discuss about consistent solution and inconsistent solution of the system. So, let's start. So, given a system of two equations, how can we tell that if the system is consistent or inconsistent, if it is dependent or independent? Let's go over the important things that one need to know. So just keep it simple, okay? If you have a system of equation that has only one solution, then it's going to be consistent and it's going to be independent, okay? If there is one solution, if there is only one solution, that is a unique solution, then the system is consistent and independent. Now, sometimes you might have many solutions as opposed to one solution. So, if you have infinitely many solutions, will it be consistent or inconsistent? Well, it turns out that it's still going to be a consistent, okay? And do you think it's independent or dependent if there is many solution? Okay, actually it's dependent as opposed to independent, okay? Now, sometimes there are going to be no solution at all. And if there is no solution, it's going to be an inconsistent system. Besides, it's also going to be independent, okay? If there is no solution, so make sure you know this information, yeah? Let's do some examples where we will see when this situation occurs, okay? So, the first example, if the row-reduced echelon form of an augmented matrix looks like this, that is, if its each column has a leading one, or we say pivot element is 1. Say for example, this column has a leading one, this column has a leading one, this also has a leading one, then the answer is we have a unique solution in this case, okay? Let me illustrate this. Say we have A equals 1, B equals 2, and C equals 3. And of course, from our last session we know this column represents U, this one V, and this column represents W. Therefore, we obtain U equals 1, V equals 2, and W equals 3. In the matrix form, we can write the solution in this way, that U, V, and W. Okay, now if the RREF has this shape, that is the left side of the line has a 0 row, while the right side is not 0. Let's say we have C something non-zero here. Then in this case we will say no solution exists, okay? For example, let's say we have A equals 1, B equals 2, and C equals 3, just like the preceding example. Then we can write that 1 U equals 1, we know here, 1 V equals 2, and observe here that 0 times W equals 3. That is, we are obtaining 0 equals 3, which is not possible, right? Therefore, because of this absurdity, we have no solution in this case. Now, what if we have 0 rows on both sides of the line? Then in this case we have infinitely many solutions, okay? Let's illustrate this. Substituting with the similar values in this case, a equals 1, b equals 2 and c equals 0. We have u equals 1, v equals 2 and 0 times w equals 0. Now observe that in this case we can substitute any number for w, yeah? W can be anything here because both side is 0. Yes? 0 times 1 equals 0, 0 times 2/3 equals 0. So w can be any real number, correct? Therefore, because of this, we have infinitely many solutions. So, we have to find solutions of this non-homogeneous linear system u minus 2v minus 2w equals a, 2u minus 5v minus 4w equals b, and 4u minus 9v minus 8w equals c. Now, as you can see, the system doesn't only have numbers and unknowns. In addition, it also has parameters a, b and c, yeah? Therefore, the solution will depend on these parameters also, yes? Apart from that, the existence of the solution will depend on these parameters too, right? And we are asked to find a solution and find when it exists, depending on the values of a, b and c. So we have did this sort of problem in our assignment in the last session, if you have gone through that, where we have seen that when we have unique solution or when we have infinitely many solution. So now let's do one thing. You pause this video, try to solve the problem and come back and compare your solution with mine, okay? So let's start by solving this system as though assuming a, b and c as numbers for the time being, okay? So we write the matrix of the system, the augmented matrix, which is clearly in this form, yeah? And now we are going to do row operation. So what we want to do is we want to get a RREF by following row operations, right? So we obtain this after some steps. So now let's think of it as a system again. Now observe that the last equation says 0 equals this expression in a, b and c, okay? So this is something to note down here. If 2a minus b plus c is some other number that is not 0, therefore as we have seen that it is never going to happen, right? So the entire system is never going to have a solution, right? So in this case we have no solution, yes? But if this is equal to 0, then what will happen? Recall the definition. So in this case we will have infinitely many solutions, correct? So in this case we get, let me write it from the last row which now becomes 0. the second row becomes 0, 1, 0, 2a minus b. And here you go, we get 1, 0, negative 2. So why we did this? Because we want to convert it into a RREF, right? We have a leading one here. So these two columns corresponding to variables u and v have pivots in them. So these are the pivot variables. And this column has no pivot. It doesn't have any leading one here, so it's a free variable, right? And now we are going to calculate the solution by picking a particular values for w and then computing for the values for u and v. You know, we have two kinds of solution in this case. One kind is a particular solution which solves this au equals c. There's only one of them, and we get it by setting the free variable, that is w equals to 0. So this is our particular solution. And the next kind is the special solution, okay? Which solve this au equals 0. So there are many of them as there are free variables. So in our case we have only one free variable, and we get it by setting the free variables w equals 1, okay. The solution that we get in this case, and of course remember this, that we are solving for au equals 0, okay. We really now don't care about what is there in the right hand side anymore, yes. So for example a or b, because everything is 0 now, okay. Therefore from the second equation we obtain that v equals 0, and from the first equation we obtain u minus 2 times w equals 0. But since w equals 1, therefore u equals 2, okay. Therefore the special solution is 2, 0, 1. And finally, all solutions now, that is the general solutions, are in the form of u equals the particular solution plus any scalar multiple of the special solution.